preferred, yeah. So I saw it. I'll get it tonight. Okay. So solution of acetic acid, and do you remember Le Chatelier's principle? Okay. If I add acetate, are you good with the equilibrium moving to the left?
Yes.
If I add in some acetic acid, the reaction goes
Right.
to the right. If I remove acetate, I take this out to the right. If I neutralize the hydronium by throwing in, say, some sodium hydroxide,
To the right.
okay. Understand how the Le Chatelier's principle works. You'll need to know that. Okay. Can I flip it ahead?
No.
Now you flip.
One
Freaking second. Okay.
All right.
Nope.
All
One more freaking second.
Yep. Alright.
I think you can write faster, right?
Right like a third grader.
He's got to be able to read the notes later. Right, Nick?
All right, you ready now?
Yeah, go ahead.
Okay. Here we go. You can read this if you'd like. You can write it down. The bottom line is, when you're looking at an equilibrium setup like this, the extent that the reaction moves to the left or the right is based on the presence of the other stuff in solution. Okay. So if you have extra, for example, acetate, the reaction doesn't move as far to the right. If you have extra acetic acid, the reaction will move further to the right. Okay. That's what this statement is telling you. And this is leading into your lab, the Ka lab by half titration. This is what this is coming to. Okay, you saw the Henderson-Hasselbalch equation. Did y'all try that? Nope. Got some head shakes. No. Head shakes. Yes.
Where would we
Buffer
have seen
solution. If you haven't written up the Ka lab, that's okay, because I haven't covered it yet. If you haven't, if you did write it up, outstanding. But if you haven't, I'm not going to worry about it because I haven't covered Henderson-Hasselbalch,
Yeah, yeah.
which is coming
I
up.
always got the first 3 times.
Okay.
That's been so
Let's go
far.
to the next one. Oh, something was happening.
When you said, when you add something to the reaction on the first one, it moves to the left. What are you adding? You're adding acetic acid?
So here, if you add acetic acid, Rosalie,
It would make it.
pushes it to the right. If you add acetate ion here, pushes it to the left.
Left. Yeah,
Okay.
yeah.
When you make a mixture of acetate and acetic acid, or a weak acid and its conjugate base, the extent that the reaction moves to the right is based on this, as well as that. Okay.
Just to the right or to the right or the left?
Well, watch. Okay, last icebox here tonight.
So is the hydrogen fluoride and the hydrogen chloride in the same solution?
Yes.
Okay.
So, first question before I flip it off of this. What do you know about HCl, strong acid, weak acid?
Strong.
Strong, okay. And strong acid's 100% associated, right? So you wouldn't write an equilibrium reaction for hydrochloric acid because it's 100% to the right. With me on that?
Okay.
Okay. And equations not there. Can I go to the dot reader?
So you said a strong acid completely associated
association for the strong acids. So I'm gonna go here.
Don't worry about it.
I have this. And then right below this, just as a reminder, strong acids, 100% H plus, Cl minus. Okay. There's no Ka because you have no equilibrium set up between them. All right. Now, here's the question. This information over here to the right, and I'm assuming you all can write an equilibrium expression off of the reaction. Are you good with this first? Like that.
Yeah.
So initially, that's what I've got. Then, where does the HCl one go? That's the next question, because it goes in the ice box.
So
It's on the H plus.
Yeah.
Okay. So this is 0.10 molar H plus, because this is 100% to the right. There's no HCl. Remember, the chloride as the anion of a strong acid has no impact on the acid and base character of the solutions. It means you're only interested in the H plus. That sits here. Initially, that's a 0. Okay. So before I go any further, if I have that and I dump in some H plus, what direction would it push the reaction? To the left, right? Okay. However, I've got a 0 right here. So now I'm making the solution that's a mixture of these two things. And I only ask that because of Le Chatelier's principle. If I've got a 0 right here and I mix this, does this go up or down?
Up.
Up. You don't know how much, but it goes up. So I'm going to say up by X. If that's the case, what has to happen to the H plus?
Up.
It goes up as well, because the reaction has to move to the right. It's a 1-to-1 ratio, so this also goes up by some amount of X. What can you say about the HF?
Goes down.
Goes down by some amount of X, okay? Here's my next question. If that's a 0, how does that the X value compare to the X value as if you put a 0.1 in here?
What?
Ready? Ask that again. So if I cover this up and I make that a 0, think about the math that you do. You get an X value. Okay. Think about Le Chatelier's principle that says if you throw in some H plus, it impacts the equilibrium. Okay. Is that X value when you put 0.1 in there going to be bigger or smaller than it would be if it was a 0?
Smaller.
Smaller. Okay. That's right, and that's because this will impact, this is that common ion statement, this will impact how far this reaction moves to the right. Don't know, I'll do two ice boxes if I have a chance. We'll do this one first, okay?
Wait, do you need to do anything with that, or just keep that in your head?
I want you to just keep it in your head, okay?
It doesn't change the math, right?
Doesn't change the math. But if I do, so like this, if I go 0.20 minus X, 0.10 plus X, and then X. And then down here, this one actually, this -4, you can ignore the X. Okay.
I thought it
So,
had to be -5 or smaller.
generally speaking, but this one you can get away with. Generally speaking.
Check.
All right, solve for X. I'm also doing this to shortcut and avoid the quadratic equation.
Which is very nice. I would like to do that with all of them.
Yeah, avoiding quadratic equation. I mean, if you put in the negative X and the positive X here, you will end up with a quadratic, and that's going to be a little messy. So by ignoring the X's, and you can do that in this case. There we go. So solve for X.